Hi. In previous time, in chapter 1, we have discussed about the two different functions. We discussed about the reciprocal functions, which have this form. That's the generic simplest form. This one in the denominator can be 2, 3, whatever, and the x can be any combination of x. So more complicated form of that could be 1 over x minus 1, or can be 1 with x plus 1. Back then, in chapter 1, we used the GeoGebra, we're going to do today, to see where this function is moving with regards to the changes from nothing here to minus and plus here. So we are going to discuss this, and also we're going to discuss about the rational functions. This is not a rational function, this is a reciprocal function. Which means the opposite of function. Rational functions are the ones that actually mean a division between two functions, like two functions dividing one another. So, for example, that function on the top that has two factors, and that function on the bottom that has one factor is a rational function. We have used these functions recently to find the areas where this function is undefined, and we have found the roots from the top part, so we were able to create what we know as sign diagram. Okay, this is what we have done until now. This lesson is about transformation of an initial function. What is transformation? Transformation means translation, which is like a vertical or horizontal movement. Translation by a certain vector, as we call. And dilation is when we stretch or shrink the function. So I want you to understand that translations, as per this formula, are occurring when we have f of x with an additional constant. Okay, so when we add something, or for example, this case is a case of translation where I'm taking away from the x a certain number, or adding a certain number. So I can have the option when I'm adding a constant outside of the function, or I can have the option where I am taking, subtracting, or adding a number within the function. I hope you understand the difference. Yes? This is within the function. This is an extra constant, adding on top. We're going to discuss that in detail, but I need, before that, to go back and discuss the general characteristics, the key points, and what we need to remember before we go further to the functions. Okay, number 1. I want you to remember that when we say y equals a over x minus b plus k, this is the basic form of a rational function. Okay, I call that here parent form, and this is kind of child because it's having something added, or it has something subtracted from the denominator, some changes that occur there. Okay, go to the next step. The next step. What each one is doing for the changes I'm interested. For example, I want you to remember that this is real when A is different to 0. That means I can never this 0. It's impossible to have a 0 here. Why? Because in that case I would have an imaginary, not a real case. And this is not something I am to discuss in this course. The second one I want you to remember, very important as well. This part gives me the space where this function is defined or not defined. So remember, in the past we did that. We say x, okay, is undefined. Let me do that better. I have to write undefined when, this is the rule, when x equals the opposite of b minus, when x equals b. That's what we have discussed in the previous lesson. That was in your test. What else I want you to remember? I want you to remember the shape. The shape of this function is hyperbole, not parabola, hyperbole. So what means hyperbole? Very important for you to remember. It is something like this and like this. Okay? It is approaching 0, but never touches the x and the y axis. Very important to remember that. Okay? That means has no, in the real form, in this form, has no asymptote in the parent form. However, in this case, when I have denominator with some kind of translation, in this case, I have asymptotes, and it's very important for you to identify the asymptotes. So in this case, asymptote is, sorry, I don't know what's happening with my pens. My asymptotes are, I have my vertical asymptote, which is always given. It's in the book. Your vertical asymptote, it is the value of the b, this part. So the area that's undefined, it is the vertical asymptote. I remind you, on the sign diagram, we used to put, this is the sign diagram, imagine that was the b, and we used to put the dotted line to demonstrate the asymptote. Also, what is my horizontal asymptote in this case? My horizontal asymptote in this case is given by k. Okay. The horizontal asymptote is the value of k. If it is nothing there, then your horizontal asymptote will be 0, nothing. If it is 4, it means your horizontal asymptote will be 4. That means, as you see in this comment here, it will move upwards. Let me highlight it here. It will move upwards. Okay. This is your A here. We call it K in the general form. So in this case, this tells me that all your function will move up by 4 in the previous example. Okay. Also, I want you to remember, we said that in the previous chapter, that this case here tells me, oh, come on. This here tells me if my function moves to the right or to the left. I want you to remember, if b is larger than 0, it goes to the right, and if b is smaller than 0, moves to the left. I have a trick to remember that. I hope it will help you to remember that. When we say b is larger than 0, you see the point of the arrow? That's the point of the arrow, moves to the right. When the b is smaller than 0, you see where it goes? That means it moves to the left. Okay. So this is what I want you to remember about the translation. Let's do some examples on the GeoGebra to see how this can apply in real life with functions. I don't know if I'm able to write here. I will be playing between the screen sketch and not screen sketch. So in this case, my graph is 1 over x. Okay, this is my green 1 over x. So I see it never actually touches. It looks like touching, but actually never touches 0, never crosses x, never crosses y. That's where we have a root. Okay. What I want you also to remember, and we have discussed that, is that when I have this function, which means when I have minus 1 over x, then my sketch is occurring. This function is 1 over x. This is minus 1 over x. Okay, so when I have minus in front, my function, my hyperbole appears in the second and the fourth quadrants. Just a reminder for those who don't remember, this is my first, second, third, fourth quadrant, anti-clockwise, moving like this. Okay, so I need to get rid of nice circle and all these things. So I'm just reminding you that when I have the positive on this side, when I have negative on this side. Okay. What else you need to remember? You need to know that because you will be asked to graph something. What else we discussed? We discussed that when I have one, in this case, 1 over x plus 2, that 2 tells me that I will move, plus 2, I will move up horizontally. That means I will go up somewhere here. My axis won't be anymore. Let me get rid of that. My axis won't be anymore that part. My origin won't be 0, 0. I will move up by 2, which means my axis, this is 5, 4, 3, 2, 1. So I will be here. Okay. My x-axis doesn't change. That means my hyperbole will move somewhere Change the color so we can see it. My hyperbole will move somewhere there and somewhere there. Do we understand that? Okay. I have to get out of the sketch pad to show you in a real. So this is my +2. Okay. This is my +2. It moves up by 2. What will happen if I have -2? If I have -2 from the original one, it will go down. So correct, when I have -2, goes down. So I'm reminding you what we said. K or A in that formula indicates the horizontal asymptote. I'm moving horizontally up or down. Let's see other changes. I'm continuing with the previous example. Remember that? Okay. When it was -1/x. What will happen if in this -1/x add 2? Will it still move up or down? Think. It's still +2. I want you to remember there are two different things. One part is, let me write it so you can see it again. I want you to remember two different things. I want you to remember -1/x is one set, and this +2 or -2 is a different set. Yeah? It's something different. So this part, -1/x, gives me that shape of the function, but the plus or -2 will tell me if I'm moving up or down. So in this case, if I use +2, it goes up. If I use -2, it goes down from my original blue. Okay. And this is what we want us to remember when we discuss translations. Of course, I want you to remember what's happening when we have movement to the right and to the left. So let me write something in this scenario. I'm duplicating the function and I have -1/x, but in that x I don't write any more plain x, I write +1. Let me delete some so you're not confused all the time. Okay. This is what I want you to remember. My original is the purple. Sorry, my original is the gray. Let me write again. The gray is -1/x -2. And then I go in this one, -1/x +1 -2. So what's happening? I'm adding 1 on the bottom. So actually, it's doing what? Try to remember that I'm in the minus territory here. So I have, for example, -5 +1 will do what? Will move to the... Remember what we said? Remember that arrow? I want you to think about this. Remember that arrow? I'm plussing 1. So what's happening when I'm plussing 1? Yeah, what happens if it is less than 0? You will have to respond that in the class, and we're going to discuss it in detail. Now, let's see what will happen if I duplicate this, and instead of having plus, I will have there minus 1. Do we see the darker gray? What will happen? It will move to the we will discuss it. Let's make another one. 1 over x plus 5. Let me delete all the previous ones so you can see a clean one. Okay. You see, my origin is not 0, 0. My origin is moving. It's here now. The plus 5 becomes the B becomes my vertical asymptote. So it will never reach the B, the 5 in this case. Okay, minus 5 in this case. What will happen if I duplicate this, and instead of having plus 5, I have minus 5? We see? It moves to the other side. It translates. And let's see how would be the original one. The original one would be 1 over x. Okay, 1 over x, the red one. 1 over x minus 5 to the right. 1 over x plus 5 to the left. Let's see if I can write something for us to understand. So 1 over x, asymptote, no asymptote, 0 to 0, my origin. If I have 1 x minus 5, what's happening? Minus 5, it is smaller than 0. So where it moves, you see that tip of the arrow? It moves towards there. In this case, 1x plus 5 is larger than 0. Do you see the tip of the arrow? It moves towards there. I hope this is clear. I'm repeating. We have the general formula. The general formula is A over x minus b plus k. This gives me my vertical asymptote. This gives me my horizontal asymptote. Okay. All this tells me that it is a hyperbole. Either this, or if it is negative, like this. Done. Let's see now what will happen to us if we are working to the next level, which is the dilation. Dilation means stretch or shrink. Okay, so I want you to understand that we can have vertically dilate. Yeah, what means vertically dilate? I have something like this, for example, and when I vertically dilate it, I make it like this. So what's happening? That original point, it moves, yeah, over here, for example, and that moves over there, that moves over there, that moves over there, that moves over there, that over there. Do we understand that? If there is a move. So vertically dilates when I have a form called C of fx. So C fx. In other words, C is a constant. So instead of having f of x, I have 3 times f of x. That means that initial point is now 3 times the distance it had initially. So it's like ballooning it. Okay, so when I balloon it, it goes further away. When I have the 3 in front of the function, becomes bigger, like the balloon opens, becomes further away. Further away from what? From the x-axis. Okay. So that happens when your C is larger than 0. But what happens if your C in this C of fx is smaller? It's larger than 0, but smaller than 1. So it's like a decimal. In this case, it goes closer to the x-axis. Never reaches x-axis, remember, it's a hyperbole. Never crosses x-axis, but it goes closer. Let's see our example in here. For example, that's my original. Yep. And I want to have it that 2 times. This is the 2 times 1 over x. So it moves further. What if it comes smaller? 0.5x, half of the previous one. It will go closer to x-axis. So let's see that. You see? I will make it bigger. And I will write here on the sketchpad for you to understand. So in this case, I have the gray, which is further away, and which is 2 times 1 over x. Okay. And I have the green one, which is my initial function, which is 1 over x. And let me change the color, and I have that blue one, orange one, which is 0.5 over x. That goes closer. That goes further out. So as I want you to understand, this has the form S of f of x. So I'm multiplying. I multiply this by 0.5. Yes, that was 1. So I multiply this by that, so it becomes 0.5 over x. Remember, we multiply only on the tops. And that was 2 times 1 over x and becomes 2 over x. Okay. What happens if instead of multiplying outside of the function, we multiply inside the function? So I have f of 2 x's. or f of half of x. Let's see, I need to get out of there. So what will happen if I have two x's? Let me get rid of the original function. So the gray one is 1 over, this one is 1 over x times 2, and this one is 1 over 2x's. So I multiply the bottom. This is multiplying the lot. This is multiplying only the x. I hope you understand what I'm talking. This is f of 2, 1 over 2x. Yeah? This one is approaching more this axis. Yeah? That was approaching the y-axis, but this one is approaching the first one, the gray one, was approaching the x-axis. The red one is approaching the y-axis. We will see more examples later. Let me get out of this to see what will happen if I have a function where it's not 1, it'll be 0.5x. The red one is 1 over 2x, and the orange one is 1 over 0.5 of x. You see the distance from the y-axis? That's what I want you to see. Yeah? You really need to know all this and understand all this. You have to practice with your own numbers until you get it, because you will be asked to draw. And our next video will be how to draw a graph given a function from its key points, key components like vertical asymptote, horizontal asymptote, y-intercept, x-intercept. Because if it moves, it translates, it may crosses the x. And of course, the roots. Because in this case, I have the undefined area. Okay, undefined area as well. Or if I have a x minus 1 on the top, I need to have a root. It will be crossing the x-axis. Okay, we're going to discuss this in the next video. Thank you.